Hello everyone. Today I am going to tell about Venn diagrams, operations on sets which include union and intersection, complement of a set and examples and solutions of exercise 1.4 from Ncert. Now I am going to tell what is a Venn diagram. We know that we can represent the sets by a roster and set builder form. We have already learned this. So we can also represent the sets by some geometrical diagrams like circles and rectangles. This type of representation is called Venn diagram. So here the universal set is represented by a rectangle and its subsets, those are related sets, are represented by circles. Here the elements of sets are written inside the diagrams with dots. If you see the examples, you will understand. For example, here representing only set A by Venn diagram. So here, for example, if you take a set that is A is equal to 1, 2, these are the elements. So we can represent this set by using circle here, and this is the set A. And here the elements 1, 2, we can represent inside the circle with dots. Like this, you have to represent. And in the second example, here representing A is subset of B by Venn diagram. We know that A is subset of B means the elements of A also the elements of B. So here A is subset of B. Then you can take A is equal to 1, 2 and B is equal to 1, 2, 3. You can see here all the elements of A are also in the B. So here A is subset of B. This you can represent like this. Here B includes all the elements of A. So you have to first draw this circle B. This is set B, and here it includes the A set also. So you have to draw one more circle here inside B, and here you have to write the elements 1, 2 with dots. These are elements of A as well as elements of B also, and there is one more element 3 that is in B set. So you have to write that element inside the B circle. So you have to put that element here outside the A set, inside the B set. This is the representation of A subset of B by Venn diagram. And next one is representing universal set by Venn diagram. We know that universal set includes all the elements of the related sets. For example, A is equal to 1, 2 and B is equal to 1, 2, 3. Then the universal set contains all the elements of A and B, 1, 2, 3. Without any repetition of the elements. So here we know that the universal set you have to represent by a rectangle. So first draw rectangle, and this universal set includes all the elements of A and B. So you have to, again here A is subset of B, so you have to first draw circle of B set and next B A set. Because B set includes the A set element, so you have to first draw B and then A. Then these are the elements of A and these are the elements of B, 1, 2, 3. And there are other elements 4 and 5 in the universal set. You have to put the elements here, 4 and 5 in the universal set. So this is the representation of universal set by Venn diagram. I am going to tell operations on sets. Those are union of sets and intersection of sets. Here I am going to tell about union of sets. We know that operations on numbers, so we use the symbols plus, minus, multiplication symbol and division symbol. Like this, we use the symbols for adding the numbers and subtracting the numbers like this. And similarly, we use operations on sets, union of sets, we use the symbols like union. For union, you have to use this symbol. So here, a union of sets means if you take two sets and all the elements of those two sets, if you write in a set, that is the union of those two sets. For example, if you take, this is denoted by this symbol, and that is you can write as A union B. And here the definition is the union of set A and set B is a set which consists of all the elements of A and all the elements of B without any repetition of elements. So here union of sets is also a set. If you see the examples, you will understand easily. These are the examples from Ncert, 12th example. Here A set contains the elements 2, 4, 6, 8 and B consists 6, 8, 10, 12. And here A union B So the union of these two sets is, you have to take all the elements of A as well as all the elements of B without any repetition of the elements. Here 6, 8 are repeating here in these two sets. 6, 8 are common elements. So you have to take only one time. So you have to write A union B is 2, 4, 6, 8 and the remaining elements are 10, 12. So this is A union B, the union of A and B. And if you take next example, A, E, I, O, U, these are the elements of A, and A, I, U, these are the elements of B. Then A union B is equal to, you have to take all the elements of A as well as all the elements of B without repetition, any element. So here A, I, U are the elements belongs to B are also belongs to A. So you have to take only these elements A, E, I, O, U. So this is nothing but A. So here if you observe, B is subset of A. That means all the elements of B are also in the set A. So here B is subset of A. If B is subset of A, then A union B is equal to A. Then if you write A union B in set builder form, here we have represented here A union B in roster form. If you represent A union B in set builder form, you have to represent like this. A union B is equal to X such that X belongs to A or X belongs to B. So here X is an element which is belongs to A or X belongs to B. And if you represent A union B by Venn diagram, so we know that when in Venn diagram we have to represent universal set as rectangle, and the other set we have to represent by circles. So if you take A is equal to 1, 2, this is A set, and B is equal to 2, 3, 4, then A union B is equal to 1, 2, 3, 4. So you have to represent like this. In A union, the elements are 1, 2, and sorry, in A set, the elements are 1, 2, and in B set, the elements are 2, 3, 4. So here 2 is common in these two sets. So you have to represent like this. This is the common element. So A union B is 1, 2, 3, 4. So this is A union B. This is A union B. 1, 2, 3, 4 are the elements of A union B. And now I am going to tell some properties of union of sets. This is first property, commutative law. If you take two sets, A is equal to 1, 2, B is equal to 1, 2, 3, then A union B is equal to 1, 2, 3, because 1, 2 are common here. So 1, 2, 3. B union A, if you union B and A, then B union A is equal to 1, 2, 3. So here A union B is equal to B union A. So while doing the union of two sets, the order in which the sets are arranged, that means if you write the order of the sets in any way, like A union B or B union A, the result does not change. So here the result is same, 1, 2, 3. This is the A union B and this is B union A. So here the result is same. So A union B is equal to B union A. So you can union the sets in any order. So therefore the union is commutative. And second one is associative law. If you take three sets, then here see these are the three sets. A union B is equal to 1, 2, 3. And here B union C is 1, 2, 3, 4. So A union B, again union C. So you have to take these three elements, 1, 2, 3. This is A union B, again C, 3, 4. So if you union these two, then you will get 1, 2, 3, 4. So 1, 2, 3, 4. And if you take A union B union C, so A is 1, 2. These are the elements of A set. So A union B union C, 1, 2, 3, 4. Then you will get 1, 2, 3, 4. So here also, while doing the union of three sets, the order in which the sets are arranged, the result does not change because the result is same here. So you can write in any order of the sets while doing the union of those sets. Therefore, the union is associative. Next one is identity element of union. If you take a set and if you union any set with an empty set means the elements of the empty set are 0. So because there are no elements in an empty set, if you union an empty set with any set, then you will get the same set. So here A union an empty set is equal to A itself, because there are no elements in an empty set. Therefore, A union an empty set is equal to A. Therefore, union of any set with an empty set will be the same set. Therefore, identity element of union is here an empty set. So the identity element of union is an empty set. And next one is idempotent law. If you take any set and if you union with the same set, you will get the same set. Therefore, A union A is equal to A. Therefore, union of any set with itself revert the same set. These are the properties of union sets. Next one is law of universal set. If A is equal to 1, 2 and universal set U is equal to 1, 2, 3, 4, then if you union these two sets, A union U, that is equal to 1, 2, 3, 4. So you will get the universal set. So union of any set with universal set will be the universal set. Now I am going to tell the solutions of question 1 to 4 from exercise 1.4 from Ncert. The first question is, find the union of each of the following pairs of sets. So the first one is x is equal to, these are the elements 1, 3, 5 are the elements of the x set and 1, 2, 3 are the elements of the set y. So if you union these two sets, x union y is equal to, you have to write all the elements of these two sets without any repetition of the elements. So if you write here 1, 3, 5, this is first set, and 1, 2, 3 are, these are the elements of the second set. And here 1 is repeating, so you can cancel 1, and 3 is also repeating, so you can cancel this. Then if you write in an order 1, 2, 3, 5, these are the elements of x union y. And second one, here in the first set A, the elements are A, E, I, O, U, and in the second set B, the elements are A, B, C. So if you union these two sets, A union B is equal to, so here A, E, I, O, U and A, B, C, only A is repeating here, so you can cancel this. And if you write in an order, A, B, C, E, I, O, U, these are the elements of A union B. And the next one, third one, A is equal to x such that x is a natural number and multiple of 3. So we know that natural numbers are 1, 2, 3, 4, etc. These are the natural numbers. And multiple of 3, multiples of 3 are 3, 6, 9, 12, etc. These are multiples of 3. So you can write, this is in a set builder form. You can write in a roster form, A is equal to, here x is a natural number and multiple of 3. So you have to write the multiples of 3, 6, 9, 12, etc. These are the elements of A set. And B is equal to, x is a natural number less than 6. We know that less than 6, the natural numbers are 1, 2, 3, 4, 5. So if you union these two sets, A union B is equal to, you can see here 3 is only, 3 is repeating here. So 1, 2, 3, 4, 5. These are the elements of B set. And the remaining are 6, 9, 12. So 6, 9, 12, etc. And if you write this in a set builder form, A union B is equal to x such that x is equal to, here 1, 2, 4, 5 are multiple of 3. Because 3, 6, 9, 12, etc. These are multiples of 3. So here you can write as x is equal to 1, 2, 4, 5. These are the elements or multiple of 3. And fourth one, here A is equal to, x is a natural number and 1 less than x is less than or equal to 6. So here x is greater than 1 and less than or equal to 6. So if you write in a roster form, A is equal to greater than 1, that is 2, 2, 4, 5, 6 less than or equal to 6. So 6. And B is equal to, x is a natural number and 6 less than x less than 10. So it is between 6 and 10. Those are 7, 8, 9. So these are the elements of B. If you union these two sets, A union B is equal to, see here 2, 4, 5, 6, there is no common element. So 2, 4, 5, 6, 7, 8, 9. These are the elements of A union B. If you write in a set builder form, A union B is equal to x such that x belongs to n, because all these numbers are natural numbers. And here if you observe, all these numbers are greater than 1 and less than 10. So you can write 1 less than x less than 10. And next one, A is equal to 1, 2, 3 and B is equal to an empty set. So here empty set means there are no elements in that set. So we know that A union B is equal to, if you union with an empty set, you will get the same set. So A union B is equal to 1, 2, 3. The second question from the same exercise, let A is equal to AB and B is equal to ABC. Is A subset of B? What is A union B? So first write the elements of A and B elements here. And yes, it is A is subset of B because AB elements belongs to A set, and as well as those elements belongs to B set also. So here A is subset of B. And if you find A union B is equal to, here if you union these two sets, here AB are common. So A, B, C are the elements of A union B. And the next question is, third one, if A and B are two sets such that A is subset of B, then what is A union B? If A is subset of B means all the elements of A are also in the B set. So then all the elements of A are also in the elements of B. Therefore, A union B is equal to B because all the elements of A are also in the set B. So it is equal to B. For example, if you see this example, here A is equal to AB, B is equal to ABCD. So A is subset of B here because AB are also in B set. And A union B is equal to ABCD. So that is equal to B. Therefore, A union B is equal to B. This is the answer here. And next one, fourth one. So here there are four sets are given, A, B, C, D. And we have to find these values. First one is A union B. So you can see here A union B. So if you union A and B sets, here 3, 4, these two elements are repeating. So you can write 1, 2, 3, 4, 5, 6. These are the elements of A union B. And next one is A union C. If you see A and C sets, here 1, 2, 3, 4, 5, 6, 7, 8. No common elements. So you can directly write all the elements 1, 2, 3, 4, 5, 6, 7, 8. And third one is B union C. So B and C, here 5, 6, these two elements are repeating. So 3, 4, 5, 6, 7, 8. These are the elements of B union C. And next one is B union D. So if you see B and D, here 3, 4, 5, 6, and 7, 8, 9, 10. So no common elements. You can write all the elements here. And next one is A union B union C. A union B union C. So A, B, C. You have to take these three sets. Here 1, 2, 3, 4 are common. So you can take 1, 2, 3, 4, 5, 6. And again 5, 6 are repeating here. So 1, 2, 3, 4, 5, 6, 7, 8. So see here 3, 4 are repeating and 5, 6 are repeating. So you have to write all these elements. And next one is A union B union D. So similarly, you can do this A union B union D. If you take these three sets, you can write like that. And similarly, you can do B union C union D also. This is an extra question. If U is equal to integers between 10 and 20, A is equal to multiples of 3, B is equal to prime numbers, and C is a set of 12 and 18, using Venn diagrams to represent the following sets. First one is A union B and second one is A union B union C. So here U is universal set, that is integers between 10 and 20. So here universal set is equal to the elements of the universal set are between 10 and 20. Integers between 10 and 20 are 11, 12, 13, 14, 15, 16, 17, 18, and 19. And we know that universal set contains the elements of all the related sets. Those are A, B, C. So here A is equal to multiples of 3. We know that multiples of 3 are 3 into 1, 3 into 2, 3 into 3, etc. These are multiples of 3. Those are 3, 6, 9, etc. But here the universal set, the elements of the universal set are between 10 and 20. So you have to take the multiples of 3 between 10 to 20. So see here in these elements, the multiples of 3 are only 12, 15, and 18. So you have to take the elements of A are 12, 15, and 18. Similarly, B is equal to prime numbers. So prime numbers, we know that factors of the prime numbers, only one in the number itself. Those are examples 2, 3, 5, 7, etc. These are called prime numbers. But here the prime numbers you should take from 10 to 20. You have to see the prime numbers between 10 to 20. So from this set, you have to see the prime numbers. So here the prime numbers are 11, 13, and 17, and 19. So these are the elements of the set B. And C elements already given. So write 12, 18. So now once you write the elements of the sets, then draw the Venn diagrams. The first one is A union B. So from these sets, first union the sets A and B. Here A elements are 12, 15, 18 and B elements are 11, 13, 17, 19. There are no common elements. So write A union B is equal to, here write in an order 11, 12, 13. There is no 14 and 15, 16 is also not there, 17, 18 and 19. Write all the elements here. Now draw the Venn diagram here. So this is the universal set and here A, the elements of A are 12, 15 and 18. So show the elements of the A set like this. These are the elements 12, 15 and 18 are the elements of A set. And for B set, the elements are 11, 13, 17 and 19. So show all the elements inside this circle, this B set. So now this is A set and this is B set. And so now in universal set, except these elements, you can see 14 and 16. So except these elements, you can see 14 and 16 elements also. So you have to write those elements here, 14 and 16. So this is the Venn diagram for A union B. And next one is A union B union C. So here A union B is, the elements are 11, 12, 13. You can see here 11, 12, 13, 15, 17, 18 and 19. And C elements also 12 and 18. These elements are also in A set 12 and 18. So no need to write extra elements here. So here A union B union C, the elements are same as A union B. But here you have to show the, in the Venn diagram, you have to show the C set also. So first draw the circle for A set. Here the elements are 12, 15, 18. These are elements of A set and B set elements are 11, 13, 17 and 19. And again C set the elements are 12 and 18. And here C is a subset of A because all the elements 12, 18 are the elements of A also. So C is a subset of A. So you have to show C set like this, 12, 18, because C, these elements are belongs to C as well as A also. So you have to show like this, and 14, 16 are extra elements of universal sets. So you have to show like this. Now, please practice these questions. These are the answers.